In the silent expanse of space, satellites orbit above, watching over our world. They track storms, melting ice, and now, subtle movements beneath Lake Mead. Not an earthquake, but a slow, creeping shift, detected by our most sensitive instruments. Lake Mead is more than a lake, it's a symbol of our ability to tame nature. Now, we've received a message from space. The ground is not as solid as we believed. The silent warning has been issued. Will we heed it? What is a seismic shift? It's not always a catastrophic earthquake. The Earth's crust is made of giant interlocking plates, tectonic plates constantly moving, drifting on molten rock. Most of this movement is incredibly slow, almost imperceptible. Imagine two heavy books pressed together. Pressure builds, energy stores, and sometimes one slips. A jolt, an earthquake. But seismic shifts can also be the slow bending and warping before the slip. The ground can stretch, compress, or bulge as stress accumulates deep within the crust. These changes aren't always at plate boundaries. Sometimes they're caused by other forces. The weight of a mountain, the melting of ancient ice, or even the massive weight of water in a reservoir can deform the ground. A seismic shift is simply a change in stress and strain within the Earth's crust, a fundamental process of our living planet. It can be slow and harmless, or a sign that pressure is building towards something more dramatic. Understanding this slow dance is key. It helps us read the planet's subtle language, distinguishing harmless groans from warning signs. At Lake Mead, this is the language we're trying to translate. The ground's movement is a message. Are we prepared to understand what it's telling us? The answer could shape the safety of millions. Seismic shifts are the Earth's way of reminding us nothing is truly still. We must listen closely. How do we detect ground movement by millimeters from space? The answer? Interferometric synthetic aperture radar, or INSAR. Satellites send radar signals to Earth's surface, then record the signals that bounce back. By comparing images from different times, scientists detect tiny changes in ground elevation. These differences create an interference pattern, a detailed map of ground movement, precise to a few millimeters. INSAR has revolutionized our ability to monitor the Earth. Before satellites, ground-based instruments gave us only a limited view. Now we see sweeping patterns of uplift and subsidence across entire regions. These satellites are tireless, precise, and never blink. They provide a continuous health checkup of the Earth's crust. We use them to monitor volcanoes, fault lines, and now, Lake Mead. The data they provide is crucial, a first glimpse at changes that could affect millions. Our watchful eyes in the sky are piecing together a puzzle. The picture they reveal is both fascinating and urgent. The future of Lake Mead may depend on what we learn from above. To grasp the gravity of the situation, we must understand Lake Mead. It's not a natural lake, but a product of human ambition, created by the Hoover Dam in the 1930s. It's the largest reservoir in the U.S. by volume, holding back the Colorado River. For nearly a century, it's been the lifeblood of the American Southwest. Lake Mead provides drinking water for millions, irrigates vast farmland, and generates electricity for 3 states. It's a cornerstone of modern life in the region. Beyond utility, it's a critical ecosystem, supporting fish, birds, and desert wildlife. But this lifeline is under strain. Decades of drought and rising demand have dropped water levels to historic lows. The famous bathtub ring marks how far the water has fallen. Now, seismic shifts add a new threat, not just to water supply, but to the ground itself. The stability of Lake Mead is in question. The consequences could ripple far beyond the desert. The slow movement beneath Lake Mead isn't the immediate danger, it's what it might signal. Geologists believe the massive loss of water has changed the weight pressing on the crust, a process called crustal unloading. Like foam rebounding after pressure is released, the Earth's crust can slowly rise. This change in stress could reactivate ancient fault lines dormant for thousands of years. Reservoir-induced seismicity has been seen at other dams. The rapid emptying of Lake Mead could destabilize the crust. The seismic shifts detected may be the first signs of this process. A significant earthquake here would be catastrophic. The ultimate nightmare. A quake near Hoover Dam, threatening its integrity. Landslides or a massive wave could overtop the dam. The dangers beneath Lake Mead are not just geological curiosities. They threaten the entire water and power infrastructure of the Southwest. The stakes are enormous. We must take these warnings seriously. In labs and agencies, scientists analyze Lake Mead's satellite data with urgency. They're not panicking, but their message is clear: something significant is happening. Dr. Alistair Finch, geophysicist, We see large-scale deformation, likely crustal rebound from water loss. The question is how this movement interacts with local fault systems. Scientists are cross-referencing INSAR data with fault maps, deploying sensitive seismometers to detect microquakes. Dr. Elena Vance, seismologist. Each microquake is a whisper from the deep. We must listen carefully. The consensus: this is not a time for complacency. Reactivating a fault can take years or decades. What we see now may be just the beginning. This gives us a window to study, monitor, and prepare. It's a wake-up call. Our infrastructure exists in a dynamic geological environment. We must reevaluate seismic hazard models for Hoover Dam and the region. Experts call for increased monitoring and updated engineering assessments. Their voices are filled with responsibility, not fear. The Earth is speaking. We must listen and prepare. The future depends on our vigilance. Lake Mead's trembling ground may seem distant, but its fate touches us all. Its stability is a matter of national security, economic stability, and environmental health. The food grown with its water feeds the nation. Its electricity powers industries. A crisis here would ripple across the country. This situation forces us to confront our relationship with the planet. We've built civilization on perceived stability, but the Earth is alive and unpredictable. The warning from Lake Mead reminds us, our actions have consequences. Responsibility falls on policymakers, communities, and individuals alike. We are all stakeholders in the Colorado River Basin's future. The satellites have given us foresight, a chance to act. We can ignore the warning or use it as an opportunity to adapt. The fate of Lake Mead mirrors our own choices. Its future and ours depends on what we do next.